Good morning, students, and it's good to be here with you as always. So let's get started. We are continuing our work with square roots, and we're also going to talk about cube roots today. But before we do that, we're going to get started with our do now, where we're going to talk about celebrating our victories. And you'll see what that means in just a minute. Our objective will be to review squares and square roots. We're also going to learn about cubes and cube roots. And students, you've made me really proud because in the last couple of days, as I have begun our discussion of square roots, a couple of you have mentioned cubes. Can you have a cube? What's a cube, Mrs. Gold? I love that you're one step ahead of me. Such hard workers. Thank you for your diligence and for wanting to work so hard and learn this. Our essential question is, how can I estimate? Estimation is a really important math skill. A non-perfect square. And what is a cube or a cube root? So our assignment, we will complete our do now, and then we're going to watch the video, which you've obviously already started doing, and we're going to complete 2 assigned pages today. And there is a special exit ticket that I want you to do. So remember, your do now and your exit ticket are done in class notebook, but your math work is done on paper because that's how we learn. So for your exit ticket today, I really want to emphasize just turning your camera on so that you can show your completed math page to me. And if it's not finished by the end of the period, show it to me anyway, okay? You get full participation for whatever you get done. And the only homework you have is just finishing up whatever you didn't get done in class. If you get done in class early, remember, I will release you, provided you do your do now and your exit ticket. So remember, let's get our cameras on for that discussion in the beginning and to show our work at the end. Remember, you want to respond when your name is called at the beginning, middle, and end of the period, and show your work on camera, or you can send a photo if your camera's not working. And there's my email address. Tomorrow, January 15th, is a half day. So check for a different calendar invite. I'm going to have to make those adjustments later today for you. And also, it's our Spirit Day. So we're going to all wear our green and gold tomorrow and celebrate our whaler pride. So here's our do now. We've still got our New Year's clocks to look at. And today it says gratitude for victories. Right, so what is that all about? We are often too hard on ourselves and focus more on our failures than our victories. What are some of the victories you need to celebrate and be thankful for? Oh, I had such trouble with those calendar invites. You all know that. Oh my gosh, what a struggle. And finally, I figured out how to do those edits and get those calendar invites fixed and get all of you guys into our class. And you guys have been so good about, checking and making sure that you got into class and making sure you got the right invite. Some of you followed up with me by email or chat. Wonderful. I'm going to celebrate my victory over the Teams calendar. So that's I'm going to actually complete it right now. So I'm celebrating. And I write in cursive sometimes because I think it's important that you learn that. I am celebrating my victory over the Teams calendar invites. And you know what? That makes me feel great. I think I deserve some fireworks. Pink fireworks, as a matter of fact. So now how do I feel? I feel pretty good. I'm not thinking about, oh, I didn't know how to fix Teams calendar invites. I'm thinking about, I'm celebrating my victory because I learned how to do it and I figured it out. So, and I got it working and everybody got to class. And then I'm going to fix it again for tomorrow for our half days. So, it's about how you look at the world, guys. Don't beat yourself up and if you don't get math the first time. Celebrate the victory of finishing the lesson. Celebrate the victory of turning your camera on during class. Celebrate the victory of doing your best work and showing your paper at the end of class. Celebrate the victory of getting started without the teacher having to ask, do you have your notes with you? Are you ready? Did you do your do now? Did you do your exit? Celebrate the victory of anything that you did well today. I said we had a special exit ticket, and this is it. We have to get really good about this. You guys, I don't know, you must think I'm a superhero because I think a lot of you think I have x-ray vision and I can read your mind, but I assure you I'm a normal human just like you. So you've got to show me your work so that I see it, okay? Let's get started with our lesson. We talked yesterday, we had a long whiteboard lesson yesterday about perfect squares. So the square of an integer, okay, an integer times itself, let's write that in. An integer, remember we're not talking about fractions and decimals when we talk about integers. So an integer times itself, or the square of an integer, is called a perfect square. So generate, that means create the first 10 perfect squares below. And we did these yesterday, so this is review. 1 squared, or 1 times 1, is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. Now, the opposite, which is what we started to do yesterday, of squaring a number, is called finding the square root. Now, positive numbers have 2 square roots. We talked about this a little bit. Why? Well, what number can you square to get to 16? You can square a 4 or a negative 4. Negative numbers do not have square roots. So they have 0 square roots. But what number has only 1 square root? 0 times 0 is 0. 0 has only 1 square root of 0. Now, the radical sign is used to indicate the square root of x. That's this. That's the radical sign. So the square root of x is used to indicate the positive square root of x. So if you're asked what's the square root of x, you would not say the plus or minus, okay, square root of x. So you're not going to do that. Because we have this symbol here, a negative square root of x, and that's what we use to indicate the negative square root of x. So with those brief rules in mind, let's complete the first 9 problems. And if you think you can do these based on yesterday's lesson, go ahead and try them yourself. Pause the video, try it yourself, and then come back to it. So the square root of 49, well, 49 is 7 times 7, so the square root of 49 is 7. The square root of 9, well, 9 is 3 times 3, so the square root of 9 is 3. The negative square root of 4, well, 2 times 2 is 4, so the square root is 2, but they asked about the negative, so this would be the negative square root of 2. Now, when you get into a number like 289, this is where you start to use your calculator, or if you've gone ahead and memorized all the perfect squares up to 20 times 20, good for you if you have, but you would know that 17 times 17 equals 289. Because they've asked about the negative square root, our solution is negative 17. And likewise, if you've memorized those square roots or use a calculator to help you, just trial and error. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. Because they've asked us about the negative square root, we need to use the negative with our answer. Now, yesterday, again, we talked about 20 times 20 is 484. So I'm going to take my calculator and I'm going to try 21. And that still would not be quite correct. But if I tried 22, 22 times 22 is 484. Therefore, the square root of 484 is 22. And now we've got some fractions. And these are actually a little bit easier. So the square root of 1 is 1. We just do the numerator and denominator separate. The square root of 16 is 4. So the square root of 1/16 is 1/4. And if you're not sure about that, you can go ahead and square 1/4 times 1/4. 1 times 1 is 1. 4 times 4 is 16. And you can prove your work. Now we have the negative square root of 81 over 25. Well, the square root of 81 is 9. The square root of 25 is 5. They're asking about the negative square root, so we need to show the negative in our answer. And for number 9, we know that 7 times 7 is 49, so the square root of 49 is 7, and the square root of 144 is 12. So the square root of 49 over 144 is 7/12. Now they're asking us to circle each value that is a perfect square. Okay, so we know 3 times 3 is 9. There's a perfect square. We know that 11 times 11 is 121, perfect square. We know that 8 times 8 is 64. And we know that 364 is, I believe, 18 times 18. So that's a perfect square. But none of the others are perfect squares. And if a number is not a perfect square, it's called a non-perfect square. So now here we're going to do some estimating of square roots. And you might want to use a calculator when you do this work. And then when we get through that, we're going to start talking about perfect cubes. So some of this you can do pretty intuitively. Some of this you might want to use a calculator to help you. So it says, what is the square root of 10? Well, it's not a perfect square. I know that 3 squared equals 9. I know that 4 squared equals 16. So 2 consecutive integers. Remember, consecutive means one after the other. So 2 consecutive integers would be 3 and 4. The square root of 10 is going to be between 3 and 4. The square root of 115, well, 10 squared is 100. 11 squared is 121. So the square root of 115 will be somewhere, because 115 is between 110 and 121. So the square root of 115 will be somewhere between 10 and 11. Now, number 12, I'm going to make a little more room so I can do some scratch work. The square root of 59. Well, the square root of 7 is 49, or the square, I'm sorry, of 7 is 49. The square of 8 is 64, and 59 falls between those. So the square root of 59 falls somewhere between 7 and 8. Now, the negative square root of 41. Well, I know that 6 squared is 36. 7 squared is 49. 41 falls in between there. We're talking about negatives here, okay? So the negative square root of 41 would have to fall somewhere between -6 and -7. The negative square root of 3, well, that's going to have to be between 1 and 2, but with the negative, because 1 times 1 is 1, 2 times 2 is 4, so somewhere between -1 and -2. These are not perfect squares, right? They are not perfect, imperfect squares. The square root of -206, well, I know that 14 squared is 196. So let's erase this and make a little more scratch room for us. So 14 squared is 196, and 15 squared is 225. And 206 falls between that. So it's going to be the square root of the negative square root of, 206 should be between -14 and -15. Now, when we're asked to approximate each square root to the nearest tenth, you really are going to need to use a calculator for this. So if I grab my calculator, and you can use an online calculator, and I look at the square root of 84, it's going to be about, and we'll use our approximation symbol, 9.2. It'd be 9.17, but we'll round that to 9.2 because it asked us to do it to the nearest tenth. So that's 1 decimal point. So the negative square root of 27 is going to be about -5.2. And the square root of 145, now if I use my calculator and I get 2 decimal points, let me show you what happens. We're going to use the about symbol. On my calculator, I got 12.04, but they've asked us to round this to the nearest tenth. If I have a 4 in the 100th place, that means the 10th place stays at a 0. So that is our final answer for that problem. Now let's talk about cubes, okay? So we talked about square roots. Let's get our scratch paper. Perfect cubes. When we talked about squares, we talked about a number times itself. When we talk about cubes, we're talking about a number times itself 2 more times. So 1 cubed, and this is what we use, the exponent of 3. 1 cubed means 1 times 1 times 1, which equals 1. So 1 is a little bit different than some of the other numbers. But if we think about 2 cubed, we're talking about 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. So 2 cubed, or 2 to the 3rd power, is 8. Remember, we are talking about repeated multiplication. Not repeated addition, okay? So I don't want to see you do this. 2 times 3 equals 6. That is incorrect if we're looking at an exponent of 3. So 3 cubed would mean 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. 4 cubed is 4 times 4 times 4. Well, 4 times 4 is 16, and 16 times 4 is 64. Now they start to get big fast, and this is what happens with exponents. So 5 times 5 times 5 times 5. 5 times 5 is 25. Whoops, I did too many 5s. Let's erase one of those. That would be 5 to the 4th power. 5 times 5 is 25. 25 times 5 equals 125. 6 cubed, 6 times 6 times 6. 6 times 6 is 36. 36 times 6 is 216. Let's go all the way to 10. So 7 cubed, 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is 343. 8 cubed, 8 times 8 times 8. 8 times 8 is 64. 64 times 4 is 512. 9 cubed is 9 times 9 times 9. 9 times 9 is 81. 81 times 9 is 729. See how quickly they get very large? 10 cubed is 10 times 10 times 10. Well, 10 times 10 is 100. 100 times 10, we add another 0 for 1,000. So that's perfect cubes. So the cube of an integer is called a perfect cube. Let's generate or create the first 10 perfect cubes below. And we've just done this work on our scratch paper. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. Now, if the opposite of squaring a number is finding the square root, then the opposite of cubing a number is finding the cube root. All integers have only one cube root, so at least that's a little bit easier. Because what numbers can you cube to get to 8? You can cube 2 times 2 times 2. That's it. If you want to get to -8, you have to use a -2. Now, when it comes to showing it with a symbol, we have the radical sign, but we will always have this little index of 3 right there. We use that to indicate the cube root of x. So cube, when we're talking about cubing, we're talking about 3. Think of a box with 3 dimensions, a cube. It has length, width, and depth. Excuse me, students. So let's find the cube root of each of these. Well, what can what times what times what will get me to 64? And the answer is 4 times 4 times 4. So 4 is the cube root of 64. So what times what times what will get me to 343? And we can even look up here. And the answer is 7. So what times what times what will get me to this -27? Well, we know that 3 cubed is 27, so -3 will get me to -27. And let's take a look at how that works. -3 times -3 is a +3. +3 times -3 is -27. Do you see how that works? Likewise, the only way to get to a -1 is to start out with -1. -1 times -1 times -1 should equal -1. Negative 1 times negative 1 is positive 1. Positive 1 times negative 1 equals negative 1. So the answer is negative 1. Now, the next one's a little unfair and a little hard. How do I get to 2,197? Use your calculator. I would try, to try out, take a guess at first. What happens when you do 12 times 12 times 12? You get 1,728. And then just try 13 times 13 times 13. And you'll find that you get to negative 2,000, you get to 2,197. They've asked about negative 2,197. And because it's a cube, in order to get a negative, we need to use a negative integer. So the answer is negative 13. And after we've done that, number 24 seems easy. Let's go back up to where we generated the first 10 perfect cubes. We see that the cube root of 512 is 8, because 8 times 8 times 8 is 512. So you've worked pretty hard today and had some unusually new concepts. What I'd like you to do for your exit ticket is to make sure that you've taken that final step of showing me your work. Suppose you worked 5 days a week, Monday to Friday, and your boss said to you, I want you to, come back here tomorrow morning, Saturday, and just pick up your paycheck. I'll give you your cash. And if you didn't pick up your paycheck, that would be kind of dumb, right? I mean, you want to get paid. Well, when you guys show me your work, that's like picking up your paycheck. I mean, there's your grade. Now you're getting your grade for showing all your hard work. So don't be somebody who does all the hard work and then never shows it to the teacher for their paycheck, which is the form of a grade. So make sure that you show me your work. You guys have been working hard. So proud of you. This is a historic school year. It's, like nothing we've been ready for. The teachers have had to make a lot of changes. Students have had to adjust. You guys have just been wonderful, and it's a real delight to teach you. So keep working hard, because as you do, you'll be great.